if this is working. Give me a quick second to double check. It says that I'm currently live, so that's good. But there, I think we got it. Oh man. YouTube is definitely making things weird. Not too sure why that wasn't working properly. Sorry about that. Tonight I'm starting a little bit on time, I guess. Just a little bit, a few minutes late because of technical difficulties once again. I'll sort this out. Hey Nomad, welcome. I need to mute everything here. Okay, I will shut this down for a quick second. Okay, perfect. Right on. Okay, yes, Cynthium Live Hack. Tonight, it's the Treat-o-matic 2020 once again. We're getting closer to Halloween, and I need to get this thing finished up. And so, I've actually been working on it just for a couple hours already, doing a few changes. I soldered in a new amplifier board for the audio amplifier. If you'll remember last time, we had some horrific noise coming from the old amplifier, and I figured that it was probably just maybe a really noisy or cheap audio amplifier. We'll see if this one works out a little better. It's got shielded cables. It's got, I think, a better chip on it. Fingers crossed. We'll see. And tonight we'll also be working on a new display that I found for this thing. So I found a VFD, they call it, vacuum fluorescent display. And so if you have seen these on cash registers, it's the very same kind. So these guys, they light up a kind of like a teal color. They use high voltage. Look on the back here, there's a big transformer on there, and a little boost circuit. So it actually has a USB jack, so it steps up the voltage from 5 volts to whatever this thing needs. I have no idea, I haven't really looked into it, but I'm guessing it's like probably 200 volts or something, 2 to 400 volts to make that vacuum fluorescent display start fluorescing. So we're going to be putting that on our robot, and I'll show you a little bit about how that's going to go in, and we are also going to probably design a bezel for that to mount it inside of the Treat-o-matic. Alright, so I'll show you my work area here, see what we're working with. So we're going to get this guy into here and mount it somehow. It would be nice to have this this power LED kind of visible, so we see what's going on with the... Oh, sorry. It'd be nice to have this power LED visible so we know what's going on with this display, see if it's communicating properly. And yeah, actually I could probably plug it into something and show you. Yes, I think I can plug it into this guy over here. So get rid of the mouse for a second here, and we will put the display here, and we will plug it in. USB has to go upside down here. I have, oh yes, I guess some of the changes I'll show you before I plug that in is that I added a fuse right here. Sorry, can't really see that. I'll move it in a little closer. So this is a classic automotive fuse. I put a 5 amp fuse in there because I don't think we'll be drawing anywhere close to 5 amps, but that way if we do get close, it'll blow right away. I added that amplifier, you can see over here. I added a new
HDMI cable because the last one was finicky and it was not displaying properly. Kept on cutting out. Everything's good now. I moved the USB hub here and then powered it via external power. So we're getting 5 volts from this power supply here, and so we can tap off that 5 volts off the switch and go right into here and power that hub externally, because this guy needs about, I think it's like 800 milliamps to run completely on. Less than that if if it is, you know, displaying only a few characters. So we also added this. This is an external power for our Arduino. That's going to be having the, well, it actually already has the EZB firmware on it, so it'll run an ARC. And we modified this Arduino Nano to have a GVS rail on it, so we can run servos and also, well, in our case, DC motors with servo electronics. And also we'll be able to hook up all the limit switches to this, so it'll detect when a limit switch gets activated. So this guy, make sure I got the polarity correct, plugs in right here, and there we go. So you can see the LED turned on there. So we'll find a place for this, and then it will hook up to the USB hub and then communicate to the AtomicPi board, which we're using as the computer for this crazy robot. So let's plug this guy in and see what happens here. Okay, the power LED is on. My hope is that, okay, yes, we have something displaying. It says LCI, something about version 1.28. Oh, darn it. I'm trying to show you it and it's outside of the viewable range. So let's try that again. I'll pop it out. All you can see right now is the cursor, so pop that out for a second and try it again. Okay. And I'll move it slightly closer so you get a better view. Okay. There we go. So it looks pretty nice. I like VFDs. They're my favorite type of this character display. So, yeah, that's working. We can actually, you know what? Let's give it a test while we're here. I installed the drivers before I started here. Alright, there we go. And, oh yes, I don't have a mouse, so I'm going to have to unplug something here. Unplug a few things. I do have a trackball on my keyboard, but it's definitely not ideal. I actually don't even know if it works. Okay, so I will back this up a little bit. So you can kind of maybe see the screen. No, it's not going to work that well. I could use another camera to look at the screen. Yeah, let's do that. Although my big head will likely be in the way a lot of the time. Here, I'll move this down. Okay, give me a sec here. Hey PTP, welcome. Good to have you guys here. Okay, let me switch up the view. Let's just do this view.
Okay, there you go. You can kind of see what's going on the computer. I don't know if I can get any closer. No, that's about it. Alright, so what I'm going to do is add a script. So we have Arc running on this AtomicPi right here. And it's not blazing fast. It, it definitely takes a little bit of time to do any actions on this guy, but I'm pretty sure it's going to work out just fine. Doesn't need to be too fast. Okay, so I think I still have a script copied into the clipboard. Give me a quick second to see if it will paste into there. It's an easy script, so that's perfect. Yes, great, it's there. So what you have to do with this VFD is to, here actually, you guys probably can't see it from that angle, so there we go. So you have to open up the COM port, and then you have to write to it. And I did have some extra code here that I don't really need, so I'm just going to comment that all out. And what I need to do is actually see which COM port this showed up as. So I'm going to right click on the Windows logo, go to Device Manager, and check out which COM port it installed on. Yeah, sorry that you can't see the screen that well. I may try to incorporate this screen at some point. We'll see. Okay, it showed up as COM3, perfect, because I have all my code set up for COM3. Okay, so we're going to hit start. I have the script that says open up COM port 3 and write something. There we go. You can't see that probably very well. I'll switch to the other view so you can see that a little better. The formatting is not that great, but so we are VFDing. And it kind of looks a little bit blurry there, but check out what it says and see if you recognize what movie that is from. I thought it was a little bit of a funny reference, but not everyone may appreciate, you know, the 80s and movies from the 80s, like I do. For those of you who can't see it, it says, "Hello, would you like to play a game?" Throw up your guesses from what movie that's from in the chat box on the side of the live stream. Okay, so we have the VFD working with this whole setup. That's like what we definitely wanted to do today. That's one of the, check that off the to-do list. Now we need to mount this thing. So we're going to move over to the other side, take some measurements, likely get into Tinkercad and start designing a 3D design for mounting this display in there. Oh, I forgot to tell you guys. I recently, some friends of mine and myself went in to purchase a Muse laser cutter. It's called the Muse Core from Full Spectrum Laser. And I have a laser cutter in my garage, so I was able to actually cut this. Just crazy. It's here, I'll give you a better view. This is going to be mounted on the Treat-o-matic itself and protect the display.
I want it to be in a different color of acrylic, but you know, this is all I had on hand. That was this width, which is clear. So I'll see if I can get a different color, but for now, it's a good protector of our VFD display. And I'll show you how that mounts. Quick second here. Okay, here we go. We'll switch over here. And there we go. So easy enough. I'll put a tiny bit of hot glue in there or some sort of double-sided sticky tape to make it protect the display. So the display will be mounted underneath, and so no one can touch it, or the elements can't get to it either. So we're going to have to make it fit with this guy. So this is a bit of a tight squeeze in here. I also have to remember that this is down. I kept on putting it like this and thinking that it displays like this, but that would all be upside down. That would not be fun. So the reason for this display is that we want to have sorry, not a vocal. We will have a vocal prompt, which will be the speaker in there. That's in there good. There we go. This will be the text prompt. So if there's anybody that comes up that doesn't hear the robot and what it says, they can actually just read it from the display. Or if they're hard of hearing, they also have another visual cue from the robot. So I don't suspect there's be too many people that are hard of hearing. The kids in my neighborhood all have that ability, but just in case. And also, like I said, if it's too loud and someone doesn't hear it, it'll say like, "Would you like some candy?" Then say "trick or treat," or something funny like, "Sorry, try again." Game over. And then it'll say, "Oh, okay, you, just kidding, you win," and then they'll give them some candy, some of that. Oh, wow. It looks like you guys are communicating in a different language that I don't know how to translate. Where's my Google Translate when I need it? Doesn't look like there is one. Funny. So yeah, we're going to make a mount for this somehow. So it's going to sneak in under here, like so. And we're going to try to use these brackets here to mount the display. It is a bit tight, so I'm debating about getting rid of these or chop. You know what? I'm going to chop them down and then see if I can kind of mount it on top of them. And hopefully there'll be enough room for this to go on top of there. Alright, so let's start hacking this thing. Start trimming some plastic away. Hopefully I don't make the plastic too weak. We'll see. Tonight's music is again the copyright-free playlist that I made on Apple Music. We have the music stylings of open source artists such as Tobu, Cartoon, Made Monster, and I don't know the rest. Oh yeah, there's Binar Pilot, and I'm probably not pronouncing it right because it has two dots over the A. I don't know how that sounds. I'm not familiar with the language that has that.
I know accents like accent grave and accent aigu in French, but I do not know other other ideas, other punctuation, I guess you could say. All right. One thing I forgot to cut away was this big guy. So this is one of the plastic mounts that goes to the bottom, and then the black bottom that we have all the computer electronics attached to screws into this. We actually don't really need it. I was figuring only 4 corners are really needed. So hack away, hack a day, hack away. Get rid of this plastic. And then we'll also need to get rid of this plastic over here. So I guess since last time as well, I put all the screws into this guy. So you didn't have to watch me do all that. So that guy's on there good. Access to the, I don't know, the candy storage. It's just through here. Excuse me. And I think I'm gonna, I think it was Amin, had advised me like to maybe try to lock this thing so kids, because I can almost get my hand in there to grab the candy, and kids may want to bypass the robot and go straight for the candy. So, and he was also thinking that, you know, if this thing isn't tied down, someone might end up taking it. So I figured, yeah, I might chain it down to a table or something, some way or another. We'll see.
That's not fair. I can't see what you guys are talking about. Okay. Let's throw that inside there. See how this fits. Not too bad. So my thinking is that we'll screw in the 3D printed piece from the backside into here, and then we'll have some clips that the VFD just clips into. But it looks like, if I don't drop it again, that this is working. You know what? I think I may move this LED. It's a little bit in the way at the moment. You know what? I'm just going to bend it the other way. It is helpful for troubleshooting and stuff, and making sure the display is working, but I think in this case, if we see the display come on, then we know it's working. So it'll mount like that, and this will go on top. So I think that'll work. It looks like I can maybe press the display down a little bit further. I'm gonna get my hands up under there. Okay, we can't push it down much further. I could use my heat gun and kind of melt that tab down a little further. I think the PCB is kind of getting in the way. So here, I'll try to show you. Actually, the PCB is cut out in that corner, so it's actually not that big of a deal. You know what? I think that'll be fine. This will rest up a tiny bit on this side.
I think that'll be good. Sorry about the glare.
You know what? I may not have to 3D print something for this. I was thinking about doing it because it would be nice to cover up these gaps up here. But you know, really, I could just hot glue this thing right into place. You know what? I think we'll try that. We'll flip this guy over. I'll hot glue it into place from the back side, and we'll see how it works. And I think I'll drop this down a little bit I'll use my hot air rework station to melt that plastic a tiny bit. Don't want to put this VFD in the harm's way of the hot air, so I'll move that. Okay, so we'll use this. Shouldn't take too much hot air to drop it down a little bit. There we go. Oh. We'll drop this one down a little tiny bit too. Okay, there we go.
It's looking a little better. I think it'll fit
A little nicer now. Actually, I'll wait till that cools down a little bit so I don't have to press it down too much.
So I got this, they call it a VFD, which is vacuum fluorescent display,
From a friend of mine.
I don't know where he came across it, but he got a bunch of them.
I think 3 or 4 of them, and he gave one to gave one to a friend of mine and myself. And they come from cash registers. So,
I'm trying to remember what it was actually specifically called. I think it was called a pull display. So it went on the very top of a cash register pull and give you the pricing and that kind of thing.
the beauty thing about these guys is that, yeah, they just show up as a COM port. So when you hook it up to USB, all you have to do is write to the COM port, and it goes instantly onto the screen. So I'm not too familiar. Like, I know some ASCII commands and that kind of thing, but enough to to do a few different actions on the display. But yeah, I need to brush up to see how I might be able to do it and send those ASCII commands in ARC and make this thing do what I want it to do, like clear the screen and stuff. I did find the ASCII commands to delete characters and stuff, but I haven't found a good way to clear the entire screen. So there we go. It was able to drop it down a little bit. So we'll glue this in place. I'll flip this guy over and then we'll hot glue it. Okay, I'll see if I can move this camera so you guys get a better view. There we go. Hopefully that's sufficient. Oh yeah, I guess trying to see if I can remember
what the brand was. So I know this is called an LDX 1000. Yeah, LDX 1000 pole display. Yes, there we go. It's from a company called AtomicPi. So here, let me show you on the screen here. This is the one. So that's what it looks like when it's on top of a pole, doing its thing. And this is it. This is the company right here, AtomicPi. Whoops. I jumped to Amazon, my bad. That's kind of funny. There's no direct link to that company. We'll see if I can just search it. Oh, just a bunch of Newegg and Amazon links. I think it might be, maybe the company actually switched its name, or it's called Logic Controls. Yeah, I think that maybe this company took over AtomicPi. So yeah, this is where I got the drivers for it. Logic Controls, I guess is the company called. Company name, sorry. Alright. And there's you guys chatting. It's my new live screen. Okay, so let's go back over here and hot glue this thing in place.
Yeah, they're definitely point of sale displays. So what I'll do to make sure that it's in their proper place is stick the laser cut piece into where it needs to be, and then hot glue it like that. Okay, everything's pretty tight in here. Alright, let's do this. I'm not sure like how hot these vacuum fluorescent displays get. It's gonna be a test for it for sure, to see if the display actually gets warm enough to melt the hot glue. I hope not. Looks like I need more hot glue. Gonna have to get another stick over here.
Oh, nice. Right on. Pedro's saying that he got another AtomicPi to install Windows. The process is, it's fairly simple, just installing Windows normally, but it only has a 16 gig onboard storage, so there's a few processes that you'll have to go through to try to squeeze Windows 10 onto there. If you look up one of DJ's live hacks, I believe it's the one with the upboard, he shows you how to install Windows onto like a limited SBC, and like turn off a bunch of stuff, make sure that you're not using any extra, like I think he's like deleting hibernation mode and that kind of thing to make sure like that Windows gets on there, gets on there installed under the wire of 16 gigs. It actually turns out to be like 14.9 gigs or something after what do you call that, after like I don't know what takes up that space, but after the install, that's all the 16 gigs shows up as is 14.9. But yeah, not a bad process. Just your like a standard Windows install, but
with a few caveats. Okay, let me get some more hot glue here.
Got some of the hot glue on the plexiglass there, my bad. The thing about hot glue is that it's easy to remove with a little bit of alcohol, but alcohol and plexiglass don't mix very well. If you have any micro fractures in there, the alcohol just gets in there and starts fracturing it even further. So one thing you don't want to do too much of is leaving alcohol on top of this stuff, especially if it's laser cut. You know, it's definitely going to leave some sort of fracture behind when you laser it. The edges, you know, mostly look pretty good on this, but you never know. I may end up replacing this with a different color, so it may not matter that much.
And we're full of hot glue strings all over the place here. I'll add a tiny bit more. Just put on this connector so it doesn't pop off. And the wiring.
Yeah, it's pretty tricky to see in there.
Wait for that to cool down a little bit. Forgot I need to put a little more on this side. And then, what should we do? So we could put the,
Put this thing together, remote desktop into it, which I've never done before, so I would have to figure that out. The reason why I want to remote desktop into it is that the AtomicPi only has one USB port, and then I broke that out into 3 more USB ports with a hub. But even that's not enough for, a keyboard, mouse. We have the audio circuit, which is, I did talk about maybe trying to use the onboard amplifier because it has a stereo amplifier on there, left and right channels, but it's 12 volt activated, and I kind of didn't want to use 12 volts. Worst comes to worst, I could, but I just want to use a single 5 volt supply to run this entire thing. So we're going to use USB. It also gives us a microphone input with here, I'll switch the display here so you can kind of see. There we go. So this is a USB amplifier slash microphone. So that allows us to have our speech recognition input with a little microphone that I have here, and then go to the speakers without using the onboard. Yes, you're right, actually. There is another USB port that's right here on the board. Very hard to see when it's so small, I'm sorry. But right beside the USB jack there is another USB to it. It has a weird plug. It says labeled webcam. So
I could utilize that USB port, but I think that, like I said, I think that it's just going to be easier to remote desktop into this thing, because we will have the 3 USB ports used up from, we're going to have a camera, the Arduino, and the USB audio amplifier. I don't actually know, I haven't really looked in a while. Let's have a quick look here. I don't think there's a microphone input. Yeah, it just says speaker R, speaker L, and there could be microphone input on these connectors, but it's definitely not labeled. There is a volume adjuster here that I was talking about. You probably have to hook a potentiometer up to. There's a UART right here. But I don't think I'm going to utilize any of those. I'm just going to use USB. It's just going to be easier. So, yeah, our USB ports are filled up, so we'll remote desktop in to be able to use my laptop and mouse to control this guy. While we're here, let's test out the audio amplifier with the new one that we put in here and see if it's any quieter. Well, I mean, we want it to be loud for the music, but we just don't want lots of noise. So give me a second here. All right. Let's see. Pedro's saying microphone is I2S. Oh, interesting. I've never dealt with I2S, so I think I'm going to stick with my classic USB. So, just going to rearrange these a little bit because of I don't have much clearance for these dongles. Okay. I actually have to unplug this guy for this one to fit. Okay, so I do hear a little noise coming from it. I don't think it's as bad as the old one, but definitely audible. I can try to diminish it by a little bit by, oh no, actually the volume doesn't seem to change it much. It's definitely a noise floor sort of issue. Just wondering if it's USB related. Trying to move some of these cables away. Okay, let's play some music. Oh, my bad. Can't play that because that's for the EZB. Oh man, that's nice and loud. Okay, so let's also try here. Let me switch to this view. Set up shop over here. Let's also try speech synthesis. So that's what we're gonna, and if I can say synthesis right, but that's what we're gonna be using for the robot itself. It's gonna be talking to people, so let us do that. Okay, so we want, excuse me, speech to text.
or sorry, text to speech, my bad, or speech synthesis. This is the one we want, yes.
Hello, human.
Alright, there we go. Let's crank it and see if it can get any louder.
Hello, human.
Yeah, I think that'll be loud enough.
Hello, human.
Let's see if we can write a little thing here. So has anyone got my reference yet?
Hello, human. Would you like to play game?
Whoop. A game. There we go.
Hello, human.
I'm not bringing
Would
my
you
game.
like to play a game?
So, yeah. So the answer to PDP's question is the audio amplifier requires 12 volts. Does it not work with 5 volts? The answer is no. You have to give it a separate 12 volt supply from over here. And there's not a boost circuit on here for that. So, yeah, I think I looked at the diagram and tried to figure out if there was any way that I could get 12 volts from this board somewhere, if there was any boosting or anything, and I don't think I found anything. So you have to apply an external 12 volts to get this section, this audio amplifier section here working. You can use just like a regular little boost circuit PCB, little circuit board. But I don't want to add that. Kind of a pain. It might be a little quieter than the noise that we're getting off of the speaker, which could be a plus, but it's not too bad. I don't think it's going to be noticeable when the whole thing is together. And this is loud.
Hello, human. Would you like to play a game?
I could test with the top on it and see how loud it's going to be, but I'm pretty sure that's going to be loud enough. Okay, so what's next? I kind of bypassed doing some 3D printing and designing something, so we won't be doing that today because I just hot glued stuff. Yeah, I guess you can't see that very well. Try to turn it for you. There we go, it's all hot glued in place. Let's flip it over. And seems like it's a little tiny bit crooked. This kind of stuff does bother me a little bit, but I think I'll let it slide this time. I may change it later on, but for right now it's fine. And it seems to be a little bit higher than we wanted it on this side. So, darn it, this hot glue's on here good, so we'll do the forbidden thing that I talked about, just because I know that I might not keep this. Got a tiny bit of alcohol, wipe it off quickly, and hopefully it doesn't make stuff splinter. Looks to be alright. So, there we go, that's our protection plastic, but it's not sitting very well on this side. So I may heat things up and shift it over and then make it, make it look a little better next time. Probably do that later on. Right now it's not a good time to do that. You guys don't want to see me messed around with that. So, here, let me turn this down a little bit. There we go. Okay, so what do we want to do next?
we can try speech recognition on our AtomicPi board over here. See how well it does. It is connected to the internet, so let's give that a shot. I've been wanting to test that for a little while. Okay, so we'll add the best speech recognition, which is Bing. I don't think I have to download it, so we'll see. There we go, Bing speech recognition. So right now we're basically building up our project that we'll be using. So I don't need the soundboard for the V4. Remove that out of here. We do need it for the speaker. So let's see our settings. So this has robot move forward, robot move reverse, and all that. We don't need those. So we will say trick or treat, and then we'll change this this script to activate the speech synthesis. Pretty sure there's a cheat sheet command for this. Or we can just say. Yeah, you know what? We're just going to write say. Would you like some candy? How about that? That sounds kind of creepy, but oh well. This is in the context of Halloween, so it'll be okay. So make sure we have our quotation marks there. Okay, save that. What else can we say to this robot? Give me candy, and then we'll make it say hold your horses, a classic needed phrase. Okay. And we can just remove these. We don't need them. Okay, I'll save that. Trick or treat. That's right. I wasn't speaking into the right mic. My bad. Try that again. Trick or treat. Timed out. Seems like it's not picking me up that well. We may have to fiddle around with it a little bit. Maybe adjust the gain on the microphone. So if we go to our volume settings and go open sound settings, check out what's happening with the mic. Hello. Testing microphone. Hello. Hello. Okay. So the microphone is working. Let's see if we can adjust the gain on it. Pretty sure you can. Advanced sound options. Master volume. Microphone. I thought there was somewhere you can do that. Oh, device properties, my bad. There we go. So we can increase the microphone gain. Okay, so we did that. Now we go start recording, and we go trick or treat. Trick or treat. Give me candy. It doesn't seem to be picking me up. I'll have to move the microphone here and talk into it really loud, I guess. Trick or treat. Hello. Give me candy. It doesn't seem to be picking me up. Interesting. Let's try just like a single phrase like, hello. And then we'll make it say, hi, how are you? Okay, let's try that. Start recording. Hello. 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 Hopefully I'm not screaming in your ears. Hello. Hello, hello. Interesting. Maybe this microphone isn't that great. Oh, wait.
Hi, how are you?
Or maybe I'm not waiting long enough. Because it probably keeps on picking up. So I think what's happening is that I have to say hello, and then we have to adjust the timeout. The timeout is just too long. So let's go. Max recording. Let's go 3 seconds. Okay, we'll save that. Try this again. Hello.
Hi, how are you?
Okay, let's try this again. This is working. Good. Give me candy. It says good. I'm guessing it didn't pick up the entire phrase. So let's lower the silence to 5. Increase the max recording to 4, let's say. Let's try this again. Trick or treat. Oh, it worked, but it said say is not defined. So I think I messed something up. I think... Maybe it doesn't like the question mark? Oh, my mouse is going a little weird. Well, I don't think it's a question mark because this one has a question mark in it too. And we also have strip punctuation. Seems like something is going weird with the USB right now. Not too sure what, but it keeps on dropping out. Okay, try this one more time. Trick or treat. It says again, say is not defined. I wonder if I have just some weird quotation marks in there or something. Try to like shift. Yeah, no candy for me. That's right. Okay, let's try that one more time.
Trick or treat. Trick or treat.
Weird. It says say is not defined.
Give me candy.
It says say is not defined as well. Weird. I've never run into that before. And I don't think I have to have a capital S. I wonder if it's just getting confused with the normal responses it has. Try all capitals. I don't think that's going to be the issue. Missing the magic word. That's funny.
Trick or treat. Trick or treat.
Yeah, it's still having trouble with say. Very weird.
Hello, human. Would you like to play a game?
So that's still working. Well, I have no idea what's happening there, and unfortunately I can't give you a close-up of the screen. This is as good as I can give it right now, because I don't have this monitor hooked up to the laptop. And this is a different computer that we're using. So, I don't think I'm doing anything wrong. I think it's just having some weird issue. So what I'm going to do, I'm going to save this project. And then boot it up again and see if it works. Oh. Pedro says he thinks he knows what's going on. Could be because I have the speech synthesis skill open. I'll try that.
Trick or treat. Trick or treat. No.
Still the same thing. So let's shut this down for a quick second. Yes, save the project. We'll boot it back up and see if that fixes it. It's kind of concerned about the USB dropping in and out. I don't know what that's about. I don't know if that's the keyboard or the mouse. Oh, I'm not RDPing right now. Oops. This is just all through the AtomicPi right now. No, I'm not using the remote desktop right now. If I were, I would be on this other screen, the laptop. So we'll open up this project again and see if we can get it to work. Because it was working for a moment there. Trick or treat. Oh, yeah, it's still not working. Because we got it to work when we said hello. Okay. Hello.
Hi, how are you?
See? And I have the same stuff going on. So weird. Yeah, it's the exact same script being used, all just with different text in it, so it's very weird. Just removing some capitals. See if that works. Trick or treat. No, it still picks it up as a response, but then it doesn't execute the script. It doesn't execute say. It says column 0, line 1, column 0, say is not defined. So what I'll do is not use say. We'll play some music when it. Oh, you know what? I know exactly what just happened. No. I don't know how this happened because I think I have it on Easy Script as the default, but somehow it got under JavaScript, and that's what the error is. So we'll remove that, put it under Easy Script. There. Oh man, what a dumb move. I don't know how it got under Java. It's so weird. Yeah, I think if I had it under Java, I just have to put a semicolon, and I think I would have been fine. So let's try that again. And I'm gonna try actually from further away. Trick or treat.
Would you like some candy?
Yay, it works. And let's see how far away we can get it here. Trick or treat. Oh, it said trick or treat. So maybe we have to put that as a picked up response, so, or not response, but a picked up phrase. Our treat, and then let's copy one of these. Let's just copy the same one. Make sure it's Easy Script. Yes. Save that. Okay, let's try again. Trick or treat.
Would you like some candy?
Beauty. So let's try from further away. Trick or treat. Whoops.
That wasn't fast enough. Let's bring this up to like 8 seconds.
Trick or treat.
Would you like some candy?
It works from this far away.
Okay, let's give me a little bit more time here. Let's do 11 seconds. Start recording and I'll run far away. Trick or treat! Oh no, I didn't like that. I wasn't really facing the way of the microphone, so I'll try that. Trick or treat! Timed out. Trick or treat!
Would you like some candy?
Well, that worked. I was about 4 feet away, I guess. Let's try a little bit further. Trick or treat!
Would you like some candy?
Yeah, okay. I was about 6 feet away. I think that's
Pretty good, actually. Not bad for that little tiny microphone. So we'll also have to find a good spot for the microphone, maybe near the top. And we'll probably have to put a few different phrases. I'm going to probably try it with my kids to see like what it picks up as those phrases. And I think what's going to trigger the start recording is likely the camera will pick up on movement, or we'll do a passive infrared sensor. And so when a PIR picks up a human presence close, or hopefully it's not an animal that comes close, but you know, those PIR sensors are good at detecting warm-blooded animals, specifically humans. So they're kind of tuned for our far infrared spectrum heat signature, let's say, and then that will trigger the start recording, and then I will have to keep the timeout long enough so that someone can, you know, say trick or treat. So that's the beginning of our program. We will have to add a few scripts. So the speech recognition will be running. It'll be hooked up to my Wi-Fi at home. So that'll be all good, because Bing speech recognition uses the Microsoft Bing cognitive speech, I guess, or I don't know what you want to call it, but the speech recognition API that Microsoft has. So that goes and uses their detection methods, and it's one of the best out there right now for ARC. So we'll be using that. Don't know if we'll need the soundboard. It was just good to test with. Trying to rack my mind on what else we want to do. I could check if I have a PIR sensor here. That'll be attached to the Arduino. Oh yes, we can do some Arduino stuff. We could plug this in, start controlling some motors and stuff. But oh darn! Hey Will, sorry, sorry to hear that your internet keeps on dropping. Yeah, that happens at my place at home. Here at the office, the internet is rock solid, but at home, for some reason, every night it drops around 10 to 1, sometime in that area. Must get busy or they refresh something. Anyway, I may call this hack night a little bit early. Hey, Will, but we'll see. Give me a quick second. I need to see how much snow has fallen. If the snow is starting to cover the road, then I'm a little bit concerned. But if it's still melting on the road, then we're fine. Because there's a ton of snowfall here tonight, and I don't want to be driving on slippery roads with my summer tires on, because I haven't made the switch yet. Give me 1 second. Take a drink break. I'll BRB. looks like we're still pretty good. Still melting on the road. All right. So we can connect the Arduino now. We can do maybe mount the microphone as well. So we just have to put this thing together, put some screws in it, put the top on, screws on, connect things to the Arduino. We got to give the Arduino a spot as well on here. I'm thinking I might put it on top of the USB hub right here, because I think that that's a pretty good spot, because otherwise I don't know. This is our power, so I guess it can go up there too, up in this section. See here. No, it's a bit too wide. So I think I'll put some Kapton tape on here, because this is a metal finish. I think it's anodized, so it's not conductive, but just in case, I'll put some on there so the Arduino can go right there. We also have the Arduino's USB cable. This one is a bit long. I will try to search my hardware library at home to see if I have a shorter one of these cables. This is a little bit ridiculous. And then we'll need to connect all the servo electronics to the Arduino, the limit switches, and then we can control this guy, which you can't see right now that I'm putting in. But control the arm and make it go. The one thing that kind of sucks though is that we will lose this monitor. We won't be able to see anything anymore because the HDMI will be covered up, so we will have to remote into it. Maybe I'll try that now, and you'll have to bear with me because I've never done I've never done remote desktop before, so this is going to be a learning curve. And yes, it's only October, but in Canada, especially where we're at, sorry, kind of a annoying view here. It gets cold really early in the fall. This fall we actually lucked out, and it wasn't too bad. It was, in the teens, the teens of degrees Celsius. Just pretty much all. Even in the 20s, actually, all in September and throughout October until now. Things have dipped. Now we're getting below the freezing point. During the day, it's probably around 6 or 7 degrees Celsius, and then at night, it gets down to like -3. Okay. So, let's do remote desktop because, yeah, it's time to learn. Let's do this. So, I'll probably give you guys a view of my desktop here. We'll move the chat over in the other window, so. Okay, here we go. So you guys aren't seeing that. Okay, let's go search on Windows, remote desktop. Okay, so this is what popped up. This is our little app for remote desktop. Okay, so it's asking for a computer name, username not specified. So I have to enter a full remote computer name. Example is something .fabricam.com. Interesting. Okay, so I'll check my computer name. I think it's Astro on this one, so I'm going to go into System on this computer, AtomicPi. Have a quick look here. The device name is actually much different than I thought. It says desktop dash triple D Q1 UF. For some reason, I think this is really asking for an IP address, but we'll try this. Okay, we are on the same network. Let's check here. Cynthium 2 gigahertz, I'm pretty sure. Actually, this one, let's see. No, it's on Cynthium main. 5 gigahertz. I don't know. I don't know the key. Darn. So I think I'm going to have to put it on. Let's see, where's the Cynthium guest? No, I think the guest network is shut down at the moment. This one's hooked up to staff 2 gig. Unfortunately, I don't have the password for that. So I don't think I can get us on the same network to be able to RDP into here. I'm just going to hit connect just for the fun of it. I know it's not going to find it. Yeah. Yeah, it says that exact thing, that it does not belong to the specified network. If we had the guest network up, we could do it that way, but yep, it's not happening. So, too bad, we can't do RDP right now. Yeah, I'm not an admin. Sorry guys. I'm just a humble user, so I can't have those kind of passwords. Anyway, what we can do is still use the Arduino. No, we can't because there'll be too many things. Oh wait, I lied. We can. So if we remove the audio amplifier circuit, we can use the Arduino instead. So give me 1 second, and I'm going to get some tape. We'll put it on over on this circuit here. Give me a second. I'll transition the view for you guys. I'll put it on top of the USB hub just in case, and then we'll put the Arduino on there, plug it in, and I'll just use the screen over here to start doing some stuff. Sucks because we won't be able to put this thing on there completely because the HDMI will be hanging out, and we still have to have the wires. The keyboard's wireless, but the mouse isn't. But you'll get an idea for what we can do. I believe I still have the values written down. Yeah, I have the stickers for the center values of these guys. We can plug in. No, we can't plug in the VFT either. I was going to say we could plug that in and mess around with that too. But unfortunately, we ran out of USB ports. Unless I make this guy here, the USB port, sorry, the guy, there's a connector right beside the USB 3 connector on the AtomicPi that is also another USB. I would just need to find a connector that hooks up to that. I believe it's a JST, an XH connector, possibly. 5 position. I don't think I have one of those, to tell you the truth, so we won't be able to do that. I'm going to grab that Kapton tape, be right back. So you may be asking yourself, why am I using Kapton tape? The reason is it's high temperature tape. So if the USB hub starts heating up, it won't melt the tape off of there. Like if you have electrical tape on there, it'll start getting real sticky and then gooey, and then it'll remove itself. Kapton tape doesn't do that. So Kapton tape, also called polyamide tape, or aka root beer tape as they call it in the oil patch, is some pretty handy stuff. I use it for isolating things or troubleshooting or using it for blocking heat when you're soldering with rework, with a rework machine, such as the hot air station that we have here. I'm sure it actually has some other funny names for this stuff, but the orange tape. Okay, there's a spot for our Arduino there. Let's hot glue it in place. Pop out our speaker. Okay, we'll pop out the USB hub first. Take out our amplifier circuit. Put it aside. Get that out of the way. Okay, there we go. Give me 1 second to grab the hot glue gun. I'll give you guys a better view here too, because I'm working on the other side. Here. Okay, do I want it facing this way? Oh yeah, USB plugs are upside down. Okay. Yeah, I think I'll put it this way. We have to leave enough room for... Oh, I forgot, yeah. This is not going to be activated until I apply this power to it. So that's good. So what I did with the Arduino, so I didn't want the USB hub to power the Arduino because I wanted just the 5 volts coming from the main brick to power the Arduino. So because I soldered these rails on the side, and those rails will be powering servos, so I don't want the servos to be powered from 5 volts on that USB hub. So what I did is there's a little polarity protection diode that goes from the USB connector, and then it goes down to the voltage regulator. And if you remove that polarity protection diode, it disconnects the 5 volts from the USB from the voltage input line. So I'll try to show you. I don't know if you guys will be able to see it or not. I think this is my best camera up here. So if you see up in this section up there, there is a diode missing. The diode is that big. Pretty small, I know. I just removed it with my soldering iron, going back and forth on both sides. And so now the power is isolated. Okay, so let's stick a bunch of hot glue on this guy. So if you ever need to do that, isolate the power. You now know how. Remove the polarity protection diode. Okay. Let that cool a little bit. And here's another tip for you. If you know you have an outlet that won't reach with your hot glue gun, not to worry. Your hot glue gun actually stays hot for a lot of time after you unplug it. So any hot glue gun that you have is essentially a wireless hot glue gun. It's funny that Walmart marketed one as a wireless hot glue gun because you can remove the power from it just right here, and then go around and use it as a hot glue gun for a little while until it gets cool, and then plug it back in here. But hey, all you have to do is remove it from the wall, and there you go. Wireless hot glue gun. So funny that they actually marketed it as such. They actually said on the package, wireless hot glue gun. It wasn't battery operated. It was just you remove power. It should have been marketed as a temporarily wireless glue gun. It's a bit ridiculous. Okay, our Arduino is mounted there solidly. Let's plug in. Oh, you know what? There's one thing that I forgot, and let's hope and pray that the drivers will be automatically found in Windows. Make sure my polarity is correct. Okay. It says setting up a device, USB serial. That's a good sign. Go to our device manager. And we'll see if it's actually set up or not. Something tells me no. No, it is not. So right here you can see. Actually, you can't see. My bad. Here, I'll use this camera over here. I'm not sure how well you're going to be able to see that. In the device manager here, it says USB to serial, and it has a little exclamation mark and a little yellow triangle saying that it did not install correctly. So we're going to have to go on the search for, I believe it's called the CMH 340 driver. I was lucky last time when I was using it on my laptop because I had already installed it a long time ago. Well, I don't think that's right. Let's go USB driver. Now, is it CMH or is it CHM? Or is it just CH or CM? CH. That's it. Okay, looks like SparkFun may have the drivers I need. Here we go. Drivers if you need them. Windows zip. Let's get that. Hopefully I have something. Oh yeah, Windows 10 has the ability to extract zips. What am I saying? This isn't Windows 98, Jeremy. Batman back in town? Did I say something Batman related? Back to the Batcave. Alright, here we go. It has a setup.exe. I don't like it when it has that. So I'm going to just extract it. And then we're going to go in the old-fashioned way. And oh, sorry guys. We're not going to hit. You know what? This isn't my personal PC, so let's just use setup.exe. This is the best way to get viruses is to click on, these kind of exe files.
But this PC is just a little AtomicPi, so what the heck? Not a big deal. Looks like it is installing. Success, it says. Okay, let's see if I have to... Nope. It's there. I don't have to do much else. Perfect. Okay, so what we will have to do is adjust the baud rate on this, which I forgot to do the last time. It had a bit of trouble. So EZB0 will be 57,600. Save that. Then we'll go to COM. Oh, we got to refresh because it's not appearing. So we will close and add a new connection. I wonder if there's a way to refresh the COM list without having to do this. So general, EZB connection, COM4, perfect. Change the settings. Yes, I have Windows 10 running on the AtomicPi. So I actually didn't even show that. It's been that way for a while. DJ and I one night I think he may have been doing it a different hack night, but I installed Windows 10 on there, and he helped me out to try to, it only has a 16 gig onboard storage, which I was saying earlier turns out to only be 14.9 gigs, and you have to fit Windows 10 on there. And Windows 10 likes to do updates and keep on getting bigger and bigger, so you have to, I think, select a metered connection so it stops trying to do updates. And you also have to get rid of the hibernation mode, which gives you an extra 2 gigs. And then you're able to use it as a functioning Windows 10 PC. So yeah, it's a little bit annoying. It has just enough to run Windows 10, so you do have to be careful with the amount of space you have. All right, let's hit connect, see if it connects. No. Try again. There we go. Seems like I have to hit it twice usually to make it work. Okay, we're connected to the Arduino. Now let's connect some of the motors to it. And we also add a continuous rotation servo control. Actually, let's do the movement panel. And I think we're using a number of them that are already hooked up to have some pull-up resistors on them. I think it's the first 5 digital ports. Beyond, I think it's D2, 3, 4, 5, 6, maybe 7 as well. So we'll have to use D8, D9, D10, 11, 12 for driving servos. So let's bring this guy over here. I think I'll just leave them not connected, physically connected on top of each other, and just undo this wiring so that I can stretch it over. Okay, so I don't remember what. I know that this orange and yellow wire is the claw, and this one is likely forward and back, or back and forth, one of the two. Okay, I'm gonna make sure that, okay, ground on the outside. We'll connect it to D8. Sorry, the silk screen is a little bit... It's a little bit smudgy. Okay, so let's do this. D8. And the stop value on D8 is, I think I have it at 87. So let's just put it to 88 for a second, test it. Whoops. So let's go 89, see if it goes the other way. Click the test button. It's very hard to see from this angle if I'm going on the right port or not. Oh, was not going the right way. Yeah. How are we going to do this without being too intrusive? Oh yeah, sorry guys, you're like viewing my back the whole time. My bad. Here, I'll give you this view so you can see what's going on. And I'll back this up a little bit. Okay, so I had labeled the center value as 87 on here. I don't know if that's the case still. And you know what? I'm going to change this to D12 because it's way easier to tell. Okay. Let's try 86. Well, D12 doesn't seem to be working. Let's try D11. Oops. So let's drop that down to go the other way. Maybe it's just stuck. It's kind of weird that it's not going the way we want it to go. Interesting. So let's try it out at center value. Okay. It is definitely stuck in that position. I wonder if I can actually move it myself. Nope, cannot move it myself. Since that one is stuck, let's try a different one for a moment. So this says the center value is 75. Okay, I'll hit the test button. Okay, I think that is... So what we're going to do, we have the stop value there, so we can hit it, hit the test. So I'm going to change these ones, the forward and the backward value, to be just like a couple
over and a couple under. So let's go 73. Okay, so we got 75, 73, and 77, let's say. Okay, hook this back up. So it looks like I was able to drop the down the claw, but it looks like I got stuck. So we may need to increase and decrease these. Odd. What I'll try doing is removing the claw off of there and see what I can do. So, see if I can use a ruler or something to move it off there. Because I buttoned this all up, so I don't want to go back in there and try to move it manually. Or I could do this. Or use a screwdriver. There we go. And it looks like it's twisted up a bit. Oh, I'm twisting it more. I need to twist it the other way. We're almost there. One more twist. Okay, there we go. It's all untwisted. So we'll try this. Very weird. Oh, there we go. That works. That was weird. Okay. Odd. So it's going the same direction for some reason when I hit a value above and a value below. But maybe it... I wonder if it has to drop down to be able to go back up. This is very odd. Odd behavior. It doesn't go like you would think it would. If you hit one value, it would go up and one value would go down. For some reason, both values were going down. And then when I hit the stop value again, for some reason it actually makes it work. You know what? Let's save this for a second. I think that is so weird. I just hit the stop value twice and it made it go up and then stop again. So I'm using stop and down to control this thing right now. That's really odd. Wonder if it's just a result of the way I have the electronics. But yeah, it's very odd behavior. Can't think of what the reason is why it's doing that. If I'm using stop, can bring it up and stop it at the same time. Very weird. Anyway, so that's probably what's happening with our other guy. If we use the stop value, we might be able to move it back the other way. So if we connect this guy to D10, let's say, stop value is supposed to be 87, and then let's go reverse value 90, forward value 84. Okay, we'll save that, and then we can use these two for moving it. Let me lift this up, get these electronics away from each other a bit. Weird. It started opening up the claw too. Oh, I know why. Because we're using this continuous rotation servo panel, it will, if I hit left, it'll actually send a signal to both those. Okay. That's what's going on. Makes sense now. Oh, the reason why I'm using an Arduino is that it is nice and small and cheap to go along with the AtomicPi, to be in the place of an EZB. You know, I don't really need an EZB with audio because I have audio connected to the computer, and I also don't need an EZB with a camera because I have a USB camera. So the idea of this project is to have a fully embedded robot, and when you have that, you don't really need some of the things that classic Easy Robot EZB would allow you to use, because this all is all built in to one. So all I needed was a very simple USB connected I/O controller, and a cheap Arduino does the trick. So as opposed to using an IO Tiny, which would be about $25, I believe this was like, I think around a $7 or $8 IO controller. So gonna save some money on there. So let's try going the other way. Oh, we have to use stop to go the other way. I forgot. So we won't be using a servo movement panel for controlling these servos. We'll likely just use your regular old servo control, or send it, script commands to go back and forth and down and up. I just wanted to test things out, and that was probably not a good idea to use the continuous rotation servo movement panel, because it doesn't operate that way. Because this is actually used for controlling a two-wheeled robot. Excuse me. Not a gantry system. So, my bad. Give me a moment here to collect my thoughts. So we could hook up the limit switches and do a test with that, and do like a little script that moves the gantry over all the way to the limits, and once it hits a limit switch, stop moving. So let's try something. I
I think the one of the limit switches, yes, okay, the one of the limit switches is available to me with this cover off. So I can do a test with it.
Now I just have to remember which one it is. So we also have to connect the common, which I labeled. Common is black. I will have to rest this, I guess, on top here. So common is ground. And then it'll be on this side. I think it might be the yellow wire. And let's hook that up to D2. So, I'll rest this on here for a second here. Okay, so I wish you guys could see this the screen here. Yeah, let's do it. Drop my mic down. Okay, so let's add an input, digital input. And so what we want to see here is that the digital input, read digital, you can see it over here, hopefully. See how it's read. We're going to set it up as D2. We'll call it D2 and we'll set it up as D2. And we'll save that. Okay, perfect. It says D2 is low. Now, let's check. Yeah, we got it right. Perfect. So you can see when I hit the limit switch, it turns green. Beauty. So we can write a script that moves this guy all the way over and hits the limit switch. But the annoying thing here is that my wires aren't long enough to do a real good test. I think I'll have to install this all and like remote into it to do a real good test. I don't think I'm prepared to do that at the moment because I don't have the ability to remote in. Ideally, I would have this all connected and not have to open it up again. But right now we're working with it half connected. Yeah, it's a bit of a pain at the moment. So I think I will likely do that on my spare time. Possibly this weekend. We'll put it all together. I'll remote into it at home since I have all the network keys there. And I will fiddle around and set up a script that allows the gantry to move and then hit the limit switch, stop, go back the other way, that kind of thing. And so ideally we want this guy to not go in the area of this candy area unless it's above it and it's dropping something down. So usually we want it to, I'll probably find out what values. I still haven't thought of all of it clearly yet, but I want to figure out for how long we want it to move in a certain direction and then stop, grab candy, and then we're going to try to get it to randomly or pseudo-randomly, I'd say, like go into different positions because we want it to grab a good amount of candy and then pop it down into the chute. I was thinking about 3D printing here, I'll unhook this for a second here so you can see it better. 3D printing a better candy chute because as you can see here, it actually is only made so that the candy actually just drops and settles in right here. And I think if I 3D printed a little, I guess you can call it a slide, so a kind of a curved slide, we can get the candy out in this area. a little bit in front of the candy machine and into like a sort of a candy bowl or a serving tray. So the idea is that someone can grab the candy itself and not have to reach into the machine to grab the candy and kind of like have a whole bunch of people touching the same place. So hopefully the candy will be able to be dropped and shoot out the front and land on the tray, and everything will be great. I did think about having like a little sanitation sprayer that sprays alcohol and sanitizes the plate, but I don't know. I don't think that's necessary. I think it would probably melt the candy wrappers, so it's probably not a good idea. So I think I might call it early tonight because I can't remote in and connect everything up. I'm kind of at a standstill at the moment because I just don't have enough USB ports and also don't have the ability to put it all together, which I really want to do. It's all hooked up to HDMI, and also have the wired mouse and everything right now. So yeah, I will likely cash out right away here and leave the rest for another day. I will probably work on this in my own time a little bit. I am not too happy about the noise that the audio circuit creates. I will try another USB adapter because I think I have one here. I have this green one, but I also have a gray one kicking around. There it is. Right in front of me. This guy. So I have another one of these to see if it's possibly less noisy. The changing the audio amplifier board seemed to clean it up a tiny bit, but not enough. So I'll work on that in my free time. And next week we'll probably do a bunch of testing with the software and that kind of thing. I am building up the project on the board here, so I will have to also ask DJ about some code for, or maybe even you guys actually. I might just message the forum about writing some Ascii code for the VFD's display. This guy here, because I was kind of running into a few issues when I was writing to the COM port. I couldn't seem to write an Ascii value, that's what I was trying to use to clear the display, just using a delete Ascii value. And yeah, so I'll likely ask you guys about that. I'll show you guys my sample code. I kept on getting an error about not having an array value, so I'll have to share that with you guys. And so, yeah, so we will have this guy audibly saying its responses to people who talk to it, like saying trick or treat, and we'll also have it on the VFD display, its responses and also its questions. So whatever the speech recognition is doing will also be outputted on the VFD. Other than that, like I said, we figure out the gantry system with the limit switches. I think it looks like everything with the hardware is functioning, so that's a good thing. Now, next week we'll likely focus on the software and make that all happen. So, like I said, I'm gonna call it early. I'm kind of at a standstill at the moment. I don't think I can do any more hardware-related stuff besides, I guess, adjusting the VFD. Nobody wants to see me do that because it's just me with a hot air gun, moving some hot glue around and that kind of thing. So I will say au revoir since we're doing a whole bunch of different languages here tonight. And I will see you guys next week. Have a great weekend, all. Thanks for joining, and we will see you next time. Later. And if you have snow, enjoy the snow this weekend. I know I won't be. It's winter tire time. Anyway, later. See you guys.